to you about conjugate acids and bases. Now, right now we're talking about Bronsted-Lowry acids and bases. So we're talking about that definition. Now, if you remember that a Bronsted-Lowry acid is one that donates an H+. A Bronsted-Lowry base is one that accepts an H+. So let's look at this reaction here. We're going NH3 plus H3O plus yields NH4 plus with an H2O. So let's see what's happened to the NH3. This is ammonia. Ammonia's gone from NH3 to NH4 plus. Do you see how it has gained an H plus? It's gained a positive charge. That means that it's accepted a proton, an H plus. Whereas the H3O plus has gone from H3O plus to H2O. Do you see how it's lost an H plus? So this is actually our acid, and this is our base, according to the Bronsted-Lowry definition. Why? Because an H plus has gone from here to there. That's why. Now, let's talk about conjugates. Now, the thing that is left over, what's left over from a base, is actually a conjugate acid. And what is ever produced from an acid is actually the conjugate base. Now, some students are confused by that. Some students look and say, why? Why wouldn't this be the conjugate base? Does it make sense that a base would produce a conjugate base? No. You know why? Because this reaction is actually reversible. Whatever happens when this produces this, these two can then produce this. Let's look what's happening here. NH4 plus is turning into NH3. Do you see how NH4 plus is giving an H plus to the H2O? So let's look at this side. NH4 plus actually behaves like an acid. So anytime you have a Bronsted-Lowry base that reacts with a Bronsted-Lowry acid, what results is going to be a conjugate acid. The base produces the conjugate acid. The acid produces the conjugate base. Let's do the next one. CH3OH is turning into CH3O minus. Do you see how it has lost an H plus? An H plus has gone from here to here. So this is actually our acid, whereas NH2 minus has turned into NH3. So this is our base. So what's left, CH3OH, our acid, turns into a conjugate base. And our base turns into our conjugate acid. Ooh, look at this. Do you see how ammonia is behaving as an acid in this reaction? But ammonia is acting like a base in our first reaction. Typically, we look at ammonia as if it were basic, but it's actually amphoteric. Amphoteric, do you remember what that means? It means that a substance that can behave as an acid or a base, the most famous one is actually water. But ammonia can occasionally behave like an acid as well. Strange. So you might have to, given a reaction, you might have to ID different parts of it. But this is definitely something you're going to have to do as well. I'll give you something, and I'll just ask you to write the conjugate base. So if we have to write the conjugate base, that means this is an acid. That means it's giving away an H plus. So that means it's going to lose an H, and it's going to lose a charge. Okay, the charge is going to go down because it's losing a plus charge. So H3O plus, if it loses an H plus, it's going to become H2O. Instead of plus, it's going to be neutral. H2SO4, it loses an H, so now it's HSO4. Since it lost an H plus, the charge goes down 1. HSO4 minus. HCO3 minus, it loses an H, CO3, and it loses a charge, 2 minus. HOCl is going to be OCl minus. And NH4 loses an H and loses, I think this is NH4 plus, and loses a charge. So it's going to turn into NH3. So what you gotta think is when it says write the conjugate base, you have to treat these like they're an acid. That means that they're going to be donating an H+. Now let's talk about this one. Write the conjugate acid. When we write the conjugate acid, that means everything's listed is a base, and it's going to gain an H+. That means the charge is going to go up by 1, and we're going to add an H to it. So instead of I minus, it's going to be high HI. Instead of SO3 2 minus, it's going to gain an H, SO3, and the charge is going to go up by 1, HSO3 minus. Instead of PO4 3 minus, it's going to be H, PO4. Instead of 3 minus, it's going to be 2 minus. Okay, instead of C2H3O2, don't add the H in here because the H in the front tells us it's an acid. So we're going to always put it in the front. So that's going to be H, C2H3O2, and we're adding an H+, so that negative charge becomes neutral. H2BO3 is going to become H3BO3. And again, instead of minus, it's going to be neutral. So there you have it, conjugate acids and bases.